Hello, or good morning, or good afternoon, whatever time you're watching this. Today we're going to start talking about limits for 2.1b. First, our notation. We write lim, L-I-M for limit. X approaches c, that arrow is going to mean approaches. F of x equals L. So we say this as the limit of f of x, or any function, as x approaches c is L, where L is a y value. For example, let's draw a coordinate plane. Make a curve. Doesn't have to look exactly like mine, really doesn't matter. Let's say this is the x value 2. Let's say this is 7. Doesn't really look like 7. We're going to go with that. Okay. We will say the limit as x approaches 2, because that's the x value we're looking at, of f of x equals 7. Okay. So when x is 2, y is 7. We can look at limits approaching from both sides. For example, using the same illustration, we can say that the limit as x goes to 2 from the positive side. This is from the right, because positive, basically think about it, positive numbers are on the right of a number line, negative numbers are on the left. So this is the limit as x approaches 2 from the right of f of x equals 7. So what this means is if we're going along this function and we're like, my x value is getting closer and closer to 2, oh, y is 7. Okay? We can also say, well, let's write this in words. The limit of f of x as x approaches 2 from the positive / right side is 7. Okay, so that's what that first one means. Again, positive side plus sign. The limit as x approaches 2 from the negative side of f of x also equals 7. Negative side, think where the negative numbers are on a number line, they're on the left, so approaching from the left side of the negative side. So now if we're starting here at the left of 2, we're going along the function, we're going towards 2, going towards 2, it looks like it's going to hit 7 from that direction as well. And if you're thinking like, doesn't it always? We'll get to those examples. And in words, this one is the same as our other explanation on the left, only it's the limit of f of x as x approaches 2 from the negative or left side in this case. Do a few more examples. Make another coordinate plane. I'll try to draw straight lines. So let's say x is 3. This is y is 7. And y is 10. Not to scale, clearly. Okay, so let's draw this as at the point 3, 7. We have a curve that kind of does that. At the point 3, 10. We have a curve that does that. So now the limit as x goes to 3 from the left or the negative side of f of x. Well, our function is both of these kind of goofy looking curves, okay? And usually we'll write f of x, so we're clear that that's f of x we're looking at, that's not some other function. So if we approach 3 from the negative side, so from the left, like where the function is here, we're approaching it from the left, well, it's 7. The y value is 7. But now the limit as x approaches 3 from the positive or the right side of f of x. From the right side, we're up here, approaching. Oh, we're at 3. The y value is 10. And now, since the limit as x approaches 3 from the left of f of x, since that's not equal to the limit as x approaches 3 from the right of f of x, the limit as x approaches 3 of f of x does not exist. Okay, just like in Mean Girls, the limit does not exist. Key points here. Right and left limits must be the same. Otherwise, the limit does not exist. Another way to think of this, if you pick up your pencil there is no limit. Okay, meaning if I try to draw this curve or trace this curve, say, going from left to right, if I start over here and I'm like tracing it, well, in order to keep tracing it, I'd have to pick up my pencil to get up there. Therefore, the limit does not exist. So sometimes that can be helpful. Okay, so now there's a limits practice worksheet. It's in the folder, I think right below this video, maybe after the completed notes piece of it. It says group work. Group work's a little tricky these days. You're always welcome to contact a friend or ask me if you need some help. I respond to emails pretty quick, or I try to. So I'm going to show you a couple of these just for a little more demonstration, and then I'll have you work on the rest, and the key is in the folder as well. So we have this graph. Let's do I don't know, the right column, okay? So the limit as x goes, no, we're not going to do that one. Sorry, thinking on the fly, guys. So let's do the middle column. So the limit as x goes to -2 from the left. So we're right here. The limit as x goes to -2 from the left. We're approaching. Looks like the y value is 3. What if we approach it from the right? Approaching. Oh, it's still 3. So the limit as x approaches -2, since both sides meet, they're both the same. The limit as x approaches -2 is 3. Let's look at also the limit as x approaches 3 from the positive side. So the limit as x approaches 3 from the positive side. So here's 3. As it's approaching, the y value looks like it should be about 2. The fact that there's a coordinate up here at this point is really just a distractor. It's an extra point. It looks like it should be 2. So that's really what the limit means, is like, where does the point look like it should be? Let's look on the back. Okay, so I'm going to do, let's see, how about Let's maybe do this second row here. So f of -2, that's like where is the y value, where does it exist? So -2 is here. There's a hole at 5. The filled in point, so to speak, is at 4. So f of -2 is 4. The limit as x approaches -2 from the left of f of x, or from the negative side, from the left side of there, or approaching, it looks like it should be 5. From the right, or positive side, approaching, looks like it should be 4. So now, does the limit exist? No, because the limit as x goes to -2 from the left and the right are different. So this does not exist. Okay? So that's the big thing here. Please try this on your own. At least give it a try. Check your answers. If you're having trouble, stop by office hours sometime or send me an email. Okay? That is it for today. Have an awesome day.